Just a quick glance at the firmament is enough to convince ourselves of the breathtaking diversity of our galaxy. When we look up at the stars on clear nights, we can only guess at the galactic secrets that lie dormant in the sheer, endless expanses of space. In the past decades, modern space research has reached new milestones. While we succeeded in 1969 in sending an inhabitant of the Earth to the Moon for the first time, there are still countless celestial bodies in the universe that currently elude the long arm of manned spaceflight. However, this does not mean that it is completely impossible for us humans to gain authentic impressions of the different planets in our solar system. NASA and other international space agencies have for some time been able to send unmanned probes into space, where the highly complex spacecrafts collect important data and admirable images of foreign celestial bodies. While there have already been numerous reports on Mars, Saturn, and company, in our contribution today, we want to focus on a particular object that is no less fascinating than its famous galactic neighbors. We're talking about the Jupiter moon, Ganymede. We'll look at what characterizes this natural satellite, what stunning photographs of the celestial body already exist, and what missions have been carried out to explore the moon so far. If you like our videos, please support us with a thumbs up, subscribe to Simply Space, and look forward to the videos that will be waiting for you in the future. The fascinating moons of Jupiter. About 778 million kilometers away from our blue home planet is the giant Jupiter. This giant gas planet has an equatorial diameter of an incredible 143,000 kilometers, which makes the celestial body, named after a Roman deity, the largest planet in our solar system. To orbit the fixed star of our solar system just once, the gas giant needs more than 11 years. The planet does not orbit around the Sun alone, but is accompanied by at least 79 moons. The most famous natural satellites of Jupiter are without doubt the so-called Galilean moons. These are not only the 4 best-known satellites of the gas giant, but also by far the largest. As the name of the moon group already suggests, the satellites were once discovered by the world-famous researcher Galileo Galilei. The universal scholar discovered the moons when he scanned the firmament for celestial bodies with a homemade pair of binoculars in 1610. Since then, we humans have learned about the existence of Io, Europa, Callisto, and Ganymede. Each of the 4 Galilean moons has its own special characteristics. Accordingly, the surfaces of the galactic satellites also differ significantly from one another. While the outer surface of Io is characterized by volcanic activity, the surface of Europa is crisscrossed with innumerable furrows, kilometers wide. Callisto is in turn known for its numerous craters. But what actually makes up Ganymede, which is the subject of our contribution today? Ganymede, the king of the Galilean moons. In the group of moons of our solar system, no other celestial body reaches the enormous dimensions of Ganymede. Jupiter's constant companion brings it to an equatorial diameter of 5,264 kilometers, which also gives Ganymede the title of the largest known moon in our planetary system. In detail, the satellite is even larger than the planet Mercury, whose diameter is around 4,880 kilometers. With an equatorial diameter of 3,472 kilometers, our Earth moon may not be able to hold its own, but at least the companion of our blue home planet still makes it an honorable 5th place in the list of largest satellites in our planetary system. In terms of its material composition, Ganymede is classified alongside the icy moons. This refers to the natural satellites whose surfaces, as the name of the classification already suggests, are mostly covered by icy materials. The core of the moon consists of iron. Ganymede is currently the only known moon that has a very strong magnetic field of its own. The name of the satellite comes from the world of Greek mythology. In the belief of the ancient Greeks, Ganymede represented an exceptionally beautiful man who served at the court of the gods. However, several centuries were to pass before the name Ganymede would fully establish itself. After Galileo Galilei had discovered the 4 largest Jupiter satellites in 1610, they were simply called the Jupiter moons 1 through 4. Nature and characteristics of the moon. The Galilean moons have always been characterized by their particularly high brightness. In fact, it is possible to see Ganymede and his galactic siblings with a simple telescope, just as Galileo Galilei did a good 400 years ago. If Jupiter's largest moon were not overshadowed by its fixed planet, It could even be seen in the firmament without any aid. It takes a little more than a week for the moon to completely orbit its planet. The satellite needs the same time to rotate once around its own axis. As we already mentioned briefly, Ganymede belongs to the icy moons. It should therefore come as no surprise to anyone that the surface of this celestial body is covered by an impenetrable layer of ice, several hundred kilometers thick. The outer side of the moon can be roughly divided into two different areas. On the one hand, Ganymede has a very old, comparatively dark surface part that is adorned by countless craters. The geologically much younger region is not only much brighter, but also has fewer impact holes. In addition, Ganymede has two independent tectonic plates on its surface with relatively flat mountain ranges on their edges. Some areas of the lunar surface suggest that Ganymede was once subject to cryovolcanic activity. This is a special form of volcanism, in which not hot glowing lava is ejected into the environment, but rather certain substances such as water or methane, which freeze immediately after the eruption. Based on the different craters on the outer side of the moon, scientists were able to determine that Ganymede must have been formed about 3 to 3.5 billion years ago. But today, the corresponding impact holes are comparatively flat, as the thick ice layer of the moon levels the craters over time. The largest of all craters on the lunar surface has a diameter of more than 340 kilometers. Exploration by unmanned space probes. After Jupiter's moon could be observed exclusively from Earth for many centuries, NASA began sending the first unmanned probes to the regions around Jupiter in the early 1970s. The first spacecraft to study Ganymede in more detail were Voyager 1 and 2, and the first real photos of the moon's surface were taken during these missions, which already revealed some details of the celestial body. These photos were finally supplemented by those taken during the Galileo project. The orbiter reached the Jupiter system in 1995, having left our blue home planet 6 years earlier. The Juno spacecraft is currently in the orbits around the gas giant and its natural satellites. After leaving Earth on August 5, 2011, the NASA spacecraft reached the planet's orbit in the summer of 2016, from where it's currently providing scientists with many important images and information. The mystery of the ice at the North Pole. A few months ago, the Juno spacecraft made a discovery on the large moon of Jupiter that left the experts in awe. In December last year, the probe succeeded for the first time in taking detailed photographs of the moon's North Pole. However, the nature of the ice in this region made scientists suspicious. While most of the ice surfaces on the natural satellite have a crystalline structure, the nature of the North Pole ice differs significantly from this pattern. A crystalline structure, however, is the characteristic lattice-like structure of ice crystals that are arranged hexagonally. However, the ice at the North Pole of Ganymede is amorphous. This means that the individual molecules have no recognizable order. NASA experts quickly came to the conclusion that the unusual phenomenon is due to the strong plasma radiation that prevails in the region in question. The charged solar particles thus prevent a crystalline structure from developing in the ice. One could quickly ask why only the North Pole of the moon has amorphous ice, while the other areas have a crystalline structure. As we mentioned at the beginning, Ganymede is the only known moon in our solar system that has a strong magnetic field. As a result, the plasma is diverted along the magnetic field lines to the poles of the celestial body, where it's therefore present in particularly strong concentration. At the same time, the moon's magnetic field ensures that the fascinating aurora borealis are constantly prancing around at the poles of the satellite. Mysterious auroral movements at the poles. Is there an ocean beneath the moon's surface? The discovery of the amorphous ice layers is not the only galactic discovery that brought Ganymede into the headlines. As early as 2015, some NASA experts succeeded in finding a phenomenon with the help of the Hubble Space Telescope that was a real sensation. According to this, experts found further evidence that beneath the impenetrable ice layer of the moon, there could be a gigantic ocean of liquid water. As we all know, the presence of water in a liquid state is generally considered the basic prerequisite for the emergence of living beings. Astronomers focused their attention on the unusual movements of the aurora borealis at the poles of the moon. As a result of some investigations, researchers came to the conclusion that the unusual oscillations must be influenced by a large saltwater reservoir. The water masses, in turn, cause a secondary Jupiter magnetic field to be created on the surface of Ganymede. The resulting magnetic friction should then influence the movements of the auroras. How did you like our video about Ganymede? Share your thoughts with us in the comments section. See you next time.